Hello, I'm Zahira. I'll be teaching you about Introduction to Offshore Structures. First of all, you have to understand that as we go deeper into exploration, we are experiencing a lot of oil to be found at the seafloor seabed. So you need to have a structure in order to extract those oil. So this is when you will have to use the so-called offshore structures. Offshore structures is just a platform being used to extract the oil production. You will place them in the sea. They have different types of functions, as you can see from number 1 to number 4. They can be exploratory, production facilities, storage structures, export structures. But most importantly, you will have to understand as well that the structures will have to be different according to the different water depths in the deep sea. It can be classified as shallow water condition, which is less than 500, deep water, or ultra deep water, which is more than 1,500 meters. So in short, there are two types of offshore structures. The fixed offshore structures, which is in the upper box colored by orange, and the floating offshore structures, the one below. So these are some of the examples that you will be looking into today, and I will just give you some brief introduction on what they are. But most importantly, you have to understand as well that as the water depth goes deeper into the deep ocean, different structures will have to be built according to the water depth, because the strengths will be different, because the higher the water depth, the higher the temperature, the higher the pressure. And some of these structures can be referred to different height of structures that you can see on land built by civil engineers around the world. And most importantly, it is nice to see that there have been some record data over the years on where this exploration has become as from 1940 until to the present day, as well as the cost of the amount of money required to go into the deeper exploration of the sea. So this is a very nice overview to see where these structures are. They are huge structures, gigantic structures, which are comparable to those structures that you are very familiar with. For example, the Eiffel Tower and some of those landscapes, skyscrapers building in the world. So along the way, you will be able to see how close they are to those structures on land. And this is a nice summary that you will see as different water depth is required for the exploration. Different kinds of structures will have to be built. From the left to the right, you're going to see fixed offshore structures being built. And along the way, as it goes deeper and deeper, you will have to create the so-called floating offshore structures, because the deep fixed offshore structures cannot be placed anymore in those deep ocean. And now, the first one that I like to introduce you to is the jacket platform. So the jacket platform is one of the earliest, one of the oldest structures being built. And they are normally built by tubular. Tubular is a circle, tubular structures, as you can see on the upper figure here. They can be used up to 400-meter water depth, and they have different compartments by the name of jackets, deck structure, and almost 95% of the platforms in the world are built by this checkered platform type. But the most important challenging things is when you have fabricated the offshore structures on land at the fabrication yard, you will have to transport that into the sea. So in this figure, you can see how difficult it's going to be, because you need to have a very big barge to be able to carry that, and later on you're going to place it into the deep sea. So I would advise you to go deeper into viewing how this process has taken place. Number 2, we call it gravity-based structure. By the name itself, it's just based on the gravity, and you can see it is made of concrete. There's the concrete that has been poured into the structure. You will have to understand, you will got to bring it into the fabrication and on land, but you will bring it onto the beach installation barge again. You will have to put water inside that. It's called ballast. You got to ballast, flood it, part of the structure into it, and then it will be centered down onto the ground. So the weight itself will be giving the stability. And normally we use this for 300-meter water depth. So these are the different GBS has been built according to the histories and timeline. And the third one is what we call a Jacob platform. So the name is very unique because this structure is able to self-elevate itself through the Jacob structures. Those are like the cranes that you see. Those are cranes, steel structures, and normally they have three legs, okay? And as you can see here, it's almost comparable to the height of the Eiffel Tower. So these Jacob legs will have the heli deck up on top of that. You will have the hull and you have the leg. And finally, it will be settled by a spark can. So this is how it is. You will have to bring it into the sea, transport it into the sea, install it. But when you want to install it, you have the option whether you want the legs to be buried, partially buried, or so on. So it can be penetrate to the seabed, it can be fitted with enlarged sections on some floatings and on some footings, and finally it can be attached to some bottom mat. So this is very interesting. Number four, compliant tower. It's just like a tower, stand still, strong tower, but very, very tall. It is a 3D steel truss arrangement. It is designed to withstand any movement of the waves from vertical or lateral, and normally you can place it slightly in deeper location around 900 meters. So it's even taller than the Eiffel Tower, you see. And this is how different oil production companies has evolved the height, the depth of compliant towers according to different depth and timeline. Number five, tension leg platform, or we call it TLP. So TLP is like a floater, and it is supported by tethers at the bottom of it. And normally it has big four columns, and it will be also be made by using pontoons in the ring type. So it can go deeper. It can go deeper. It can go to up to 1,500 meter water depth. There are some famous TLP in the world that you can just Google it. And these are two examples by the name of Sea Star and Moses tension link platform. The sixth candidate is spar. It's a very beautiful, slightly like a twisted structures, but it's floating as well. So the first history was when people started to use buoys in the deep sea. So this spar, it can withstand extreme deep water, and it is designed to be having different components by the name of deck, hard tank, mid section, and soft tank. And as you can see, there are different types of spar by the name of classic spar, truss spar, and self spar. And on the upper part here, these are the different evolution of different design of spars over the time at different water depth capabilities. And when you want to fabricate the spar, you will have to do it again at the fabrication yard online. It will be so huge, just like this big circle. You will have to design it. You will have to then install it, bring it into the big barge, into the sea where you want to place it, and you will ballast it. You will ballast it so the weight of the water inside the spar will have it partially being embedded and while partially being floated. So that is how the mechanism. You can also see this is a simple diagram to show the different principles and procedures that I just described to you. This is what we call the installation procedures, and eventually you will have to move them back into some hookup lines so that it doesn't go away. Candidate number 7 is having a very long name. It's like a floating production storage and offloading system, FPSO. Why? Because it can do all. It can float, it can produce, it can do production, it can store, and then later on when it stores into the deep sea, you can just offload it. Offload it. So how do you offload it? You will offload whatever oil or gas that you have stored, especially black hydrocarbon, into a tanker. The tanker will come to the FPSO from time to time to offload the amount of hydrocarbon being extracted by the FPSO. So you will need to have a hawser to do this job. So this is the upper overview of the facilities inside an FPSO. You can see the production facilities, and there goes the hawser line towards offloading. You have at the bottom on the have very huge areas where for you to store the hydrocarbon being extracted. And normally you will have to have certain amount of capability for drilling. You will see more in the next slide. So this is the compartment that has been dismantled, for instance. So you will be able to see the area of storage, area of drilling. There is a turret, and on the upper part of that, you will see a different FPSO mooring system by the turret system, because this can be the internal turret. So this is the external turret, and it can have spread mooring system. If you do not moor your FPSO, the next day when you wake up, it can just be elsewhere in the other part of the world. So you need to have a turret system designed to be embedded into FPSO, because there is when you connect all the mooring lines to just let it stay and not moving anywhere else. Okay, now let's go to see. This is the fabrication yard again, but this time of fabrication is meant for the building of FPSO. So it's huge. You see the height of paper as compared to the height of FPSO is huge. And last but not least, I'm bringing you to semi-submersible. Sometimes they call it by semis. So it is like a floater, semi-submersible platform. It can do drilling, it can do oil production, and it can do heavy lift crane. So it is a very stable, strong guy. So it has certain compartment in that, but normally it will always be in the floating position. So this is the close overview on how the different component of a semi-sub. It has derrick, it has two side, column, and pontoon. Well guys, that's all for now. That's a very short overview on the different offshore structures available around the globe. I hope you are able to search more and enjoy reading and learning about these structures. Thank you.